Today topic is haloalkanes and haloarenes, miscellaneous topics, right? Here the first one, reaction with thionyl chloride. This is also known as D'Orgen's procedure. It will follow SN1 and SN2 mechanism. From alcohol to alkyl halide preparation with the help of SOCl2, sulfonyl chloride, right? Here, the special of this reaction is we will get this alkyl halide pure compound. Why? Because this SO2 is the gas, HCl also gas. From alcohol to alkyl halide, some other reagents also are there. Example PCl5, PCl3. Okay, then but here this SOCl2 is giving pure compound. This PCl5, PCl3 is not giving. This reaction already we discussed in the first video. Now, Borodin-Hunsdicker's reaction. See, silver salts of carboxylic acids reaction with the halogen in the presence of carbon tetrachloride is giving alkyl halide. Okay, here carbon dioxide decarboxylation also takes place. AgX means like AgCl getting the precipitation. Here CO2 gaya, AgX gaya, then only alkyl will be remain. This alkyl group and X is forming alkyl halide. Okay, here similar one more reaction is there. This silver carboxylate reaction with Rx is there, suppose. Here only halogen. Here alkyl halide is there. You will get, I am taking R dash, right? RC double O R dash. This is the ester. This is also we discussed in the last classes. So nucleophilic substitution reaction. What you have to do? AgX we are removing. Of course, here also we removed that AgX. Okay, this carboxylic acid is unstable because here RCOOX there is no such type of compound. Okay, that's why here carbon dioxide released and forming alkyl halide. Here it is forming ester. Next, by halide exchange here named reactions, two named reactions are there, very important named reactions. One is Finkelstein reaction, F is there in the Sword reaction. Okay, so F is there means we cannot prepare, it is not for fluoroalkanes, it is for iodoalkanes. Okay, opposite, right? So you have to link up because in the Finkelstein there is no information. Whenever named is there, the name we have to make one story or one code form. Okay, so in the Finkelstein we are making alkyl iodide, right? From where? Generally from alkyl halides, that means chloro or bromo alkanes. So iodine we required, so we had to take iodine related compound. What is that? We are taking potassium iodide. Potassium iodide is the ionic compound K plus I minus. Okay, in the presence of acetone, this solubility is very less. Of course, Ki and KCl KCl is more ionic. It is more ionic. Okay, this ionic compound not at all dissolved. It is Ki little bit it can dissolve, right? So this iodine is a good nucleophile also. Good nucleophile. Here nucleophilicity you have to know that nucleophilic character iodine is higher than bromine than chlorine than fluorine in case of non-aqueous solvent. Sorry, in case of aqueous solvent. In case of aqueous solvent. In aqueous medium. And in non-aqueous medium, fluorine is higher than chlorine, then bromine, then iodine. In non-aqueous or non-polar condition में, this is the nucleophilicity. But the thing is here, this KCl cannot dissolve in the acetone. That's why it is getting the precipitation in the presence of acetone. But it is an ionic compound, it is a covalent compound. So this covalent compound is forming maximum in the presence of acetone, right? Next important reaction here only, Schwartz reaction. So for Schwartz reaction, we are taking heavy metal fluorides plus alkyl halide. Alkyl halide in the sense here alkyl chloride or bromide we are taking. Then heavy metal fluorides, while reacting this fluorine is exchanging the chlorine. It is forming alkyl fluoride. It is forming alkyl fluoride. So HgCl2 here. This is the Schwartz reaction. You have to remember, you have to link up first of all. The Schwartz means we are preparing alkyl fluoride. Okay, so fluorine related compound we have to take. Which compound? That is heavy metal fluoride. Okay, here the reactant, substrate you can take either chlorine or bromine. Right? Here Ri and Rf can be prepared by this method only. Why these are important? Because there is no other method. PCl5, PCl3, SOCl2, those methods are there for preparation of alkyl chloride and bromide, not for fluoride and iodide. Right? So for chlorine, so many are there. Now one more reaction is important here. We are taking SO2Cl2 is the reagent for from alkanes. From alkanes, we can prepare alkyl halides. Okay, in the presence of light and organic peroxide. What is the peroxide? Covalent peroxide. H2O2 is the peroxide. In the presence of peroxide, this is undergoing free radical mechanism. Free radical mechanism. We learned free radical mechanism in the alkanes halogenation in the presence of light. Suppose methane is there, chloromethane, dichloromethane, trichloromethane, tetrachloromethane is forming like that. So the peroxide is initiating the free radicals. The free radicals are highly reactive because see alkanes can react with only in the presence of light with the free radicals. With free radicals. Actually alkanes are paraffins, means there is no reactivity, very less reactive. Okay, how to remember this product? See the product or H is there, SO2Cl2. If you write the structure, you will get some hint for this. Okay, you remove this HCl, right? And here SO2 sulfur dioxide gas is there, right? This chlorine is remain. This chlorine is attacking there, over, right? Like this. So your product, main product is RCl. Byproducts are HCl and SO2. Next, Borden-Hunsdiker reaction. I think we discussed this one. Yeah, already it's over. Same reactions repeated. Now, next, Sandmeyer reactions. The Sandmeyer reaction already we discussed, but again, revision it is Sandmeyer and Gutterman. Gutterman. Similar reactions are there. So in the Sandmeyer reaction, sand S is there, that is cuprous plus 1 oxidation state. Cuprous chloride we are taking plus 1. Of course, we can prepare here only here X means chlorine comma bromine. Chlorobenzene and bromobenzene we can prepare. The byproduct is nitrogen gas. Nitrogen gas. Okay. Here this benzene diazonium chloride is releasing. This chlorine is attacking here. Substituting we can say. Now Gutterman reaction is same react substrate is same benzene diazonium chloride we are taking N2 plus Cl minus plus the Sandmeyer cuprous chloride and HCl, right? In the Gutterman reaction we are taking copper plus HCl, copper plus HCl. Here only copper we are taking. Okay, then the product is chlorobenzene, right? Like this. Here, one more important. If you want to prepare iodobenzene and fluorobenzene, again these are also specific reactions. Like alkyl iodide and alkyl fluoride we discussed. Like that, Abhi, aryl iodide and aryl fluoride. Again, these are also very specific. Here, aryl iodide is very simple. Just this diazonium chloride N2Cl is released by I minus. For that we are taking just Ki, that's enough. But fluorobenzene is little difficult. So we are taking first HbF4. So how to remember this? See, we need the fluorobenzene, fluorine. So fluorine agent we are taking, that is BF3. Okay? But BF3 is not, BF3 is the BF3 is the electrophile. Okay, so we are taking in the presence of HF, in the presence of HF, it is forming HbF4 minus. So either H plus FbF4 minus. Okay, so here in the benzene diazonium chloride N2 plus Cl minus. So one nucleophile can replace by one nucleophile only. So see here the Cl minus replaced by BF4 minus. Yes, see clearly. Then internally exchanging this diazonium, this N2 is a good leaving group. So here N2 is leaving, one fluorine is attacking there. So BF4 में one fluorine is attacking there means बच गया कितना BF3. Okay, this is the reason we are taking. Here first we are replacing Cl minus, that's why we need anion. So the anion type, what is there? Fluorine agent HbF4 minus we are taking. H plus Bf4 minus, that is the neutral compound only. Next, Huns-Dicker reagent, Huns-Dicker reaction. Already we learned just before in case of aliphatic RCOOAg plus chlorine carbon tetrachloride, we got it RCl. Byproducts are carbon dioxide and AgCl. Same reaction here also. It is releasing as CO2, AgCl. Okay. This name you have to remember. This is a Huns-Dicker reaction. Huns-Dicker reaction. Okay. Next, Raschig process. Raschig process. Here, chlorobenzene we are taking. This chlorobenzene, it is similar to Sandmeyer reaction again. Cuprous chloride we are taking, but oxygen in the presence of oxygen. Another name is there is a Raschig process. This name is important. The bulk process, industrially we are preparing chlorobenzene by Raschig process. Right? Now over. If you want to prepare geminal dihalides, okay, gem dihalides, what to do? Just you can take aldehyde or ketone. You can take ketone also. CH3 C double bond O CH3. Okay. So by taking PCl5 or PCl3, these reactions are giving dihalides. OB on same carbon, two chlorines are there. That's why this is a geminal dihalides. Okay. So this chlorine, this oxygen is released here. Two chlorines are substituted on the same carbon, carbonyl carbon. So name also important here. This is ethylene chloride. On same carbon, if two halogens are there, that is geminal. That's a common name. In the name, while you are giving the name for the compound, you have to take the suffix is id, idene, idene, right? Ethyl idene. CH3, CH2, that is ethyl. In the ethyl, two chlorines are there, ethylidene chloride. And one more process is there to prepare this geminal. So H plus Br minus is there. So according to Markovnikov rule, this Br minus is attacking where less number of hydrogens are there. That means CH3 CCH 2 times pi bonds. So that's why 2 times the bromine is attacking on the middle carbon. So finally you are getting this. IUPAC name of this compound is 2 comma 2 dibromopropane. 2 comma 2 dibromopropane. Next, if you want to prepare vicinal dihalides, you can take like this double bond, addition of bromine in the presence of carbon tetrachloride. Here, the important thing is cyclic bromonium ion mechanism. Bromonium ion mechanism. It is following. Intermediate. This is the intermediate it is forming. Then it is forming like this. So, in case of if it is chiral carbon, we have to consider stereochemistry is important. Stereochemistry required. Okay, if it is chiral carbon means that clockwise rotation, anti-clockwise rotation, RS nomenclature we have to give. But here there is no chiral carbon, it's a very simple reaction. So first of all, vicinal, if you understand, it's okay. This is the next advanced level, right? Now, if you want to prepare in any other methods like this, you can take wherever OH is there, the OH is replaced by halogens easily by PCl5 like this. So you are getting CH2OH, CH2OH, right? This is also one of the method, vicinal dihalides. Next, reactivity of this chlorobenzene. So generally, chlorobenzene note point is here. Chlorobenzene reactivity and a normal benzene reactivity say कम रहता है. It is important reactivity. Why? Because here chlorine is plus mesomeric as well minus inductive. Minus inductive means electron taking from benzene. So here especially here minus inductive effect is higher than the plus mesomeric effect. Okay, so benzene is highly reactive than the chlorobenzene is very important. Very important question. Okay, because whenever minus inductive is there, obviously ortho and meta substitution reactions should be takes place. But here ortho para directing group. Here the chlorine is Chlorine is ortho-para directing group. Ortho-para directing group. What is that ortho-para directing group? See, in the chlorobenzene, if you do the nitration, obviously on the ortho position and para position, nitration takes place. If only one nitro is there, means obviously para position it will come. If two times is there, ortho and para. If three times is there, two ortho position and para position it will come. Now, reactivity order. If you take 3 nitro and 1 chlorine is there, so see towards nucleophilic substitution reaction. Nucleophilic substitution reaction means the chlorine should be replaced by OH minus, right? Here this chlorine easily can release from the benzene. Why? Because NO2 is the creating at ortho position positive charges and para position positive charges. This NO2, that NO2 also generating positive ortho position and para position. This NO2 also creating ortho position electron deficiency, then para position. So this much of electron deficiency is creating. So if a nucleophile is there, strong nucleophile outside OH minus, this OH minus immediately attacking on the at this position. So chlorine ko hatate. Okay, well OH minus is attacking there, chlorine minus is releasing. So this is the process. So here only two NO2 groups are there. So compared to less reactive, here one nitro, there is no nitro means it is hard, very difficult to prepare phenol. Phenol preparation is very difficult. Of course, hey, that is a Dawes process is there, but Dawes process is there. Dawes process is there. That is extreme conditions. Extreme condition 300 atm and 650 Kelvin like this. Okay, next. Here one more reaction KNH2. This KNH2 came for dehydrohalogenation. Halogenation. It is a strong, I can say, strong dehydrohalogenation. So here bromine is there. So from next carbon, hydrogen, it is releasing as HBr. So it is forming intermediate is benzene. It is forming intermediate is here. This is called benzene. Benzene. Next this NH3 and here NH2 minus is there. This NH2 minus is attacking from this hydrogen total. One side hydrogen, one side NH2. Okay. So just addition reaction type HBr जैसा this H and NH2 is attacking and finally forming this aniline. I will take one more example for this. Suppose here methyl is there. Next position here chlorine is there, right? In this case, two probabilities are there. Methyl. So what I told you, benzene structure is forming, right? This is the one structure. Intermediate this one. CH3. This chlorine can take the para hydrogen also. Like this also one more probability is there. So these here now NH3. NH3. Here H NH2 meta position. Here NH2 is the para position. Okay, like this possibilities are there. NH2 minus. Chlorine, it can form. See, here hydrogen is there, here hydrogen is there, so it can take this hydrogen also and this hydrogen also. Two probabilities I written here, right? Now it is creating a ortho position negative charge and para position negative charge and ortho position negative charge. Okay, so H plus NH2 minus. Okay, we will discuss. I will give one more example later. Last with chloral. This is the chloral CCl3CHO. This is the common name of chloral. We are taking chlorobenzene. Here, this oxygen and this chlorine, oxygen and this hydrogens, para position hydrogens, just removed and forming like these two phenyl groups. Okay, this name is DDT. It is insecticide. It is very important. Para dichloro diphenyl trichloroethane. That name is. See, first of all, name is here. 1, 2 carbons are there. So eth. Single bond is there. Ethane. Okay. Now prefix, suffix, not sorry, prefix. So 3 chlorines are there. So trichloro. We can give 1 comma 1 comma 1 also. 1 comma 1 comma 1 trichloro, and this is the phenyl diphenyl, but diphenyl with chlorine also is there. That position is para position. So para dichloro diphenyl. Okay, one more is para dichloro diphenyl. Okay, so para position में I can replace with 4 comma 4 also. 4 comma 4 dichlorodiphenyl, 1 comma 1 comma 1 trichloroethane. This is like this you can write the name. Electrophilic substitution reaction already we discussed, but here the short note. In the presence of FeCl3 or any FeCl3 or AlCl3, this Friedel-Crafts reactions takes place. These functioning is creating electrophiles, Cl minus or CH3 plus or whatever electrophiles. Depends on this. Here Cl plus is there. The Cl plus will be attacked at ortho position and para position. Just before we discussed, the chlorine is ortho para directing group. Ortho para directing group, why? Because ortho position and para position it is generating negative charge. Okay, chlorine is ortho para directing group. Next HNO3 is there. Here important is there. This HNO3 में electrophile क्या है? Electrophile है NO2 plus. So how we came to know that? So you can write HNO3 में OH and double bond O. This is the HNO3. Then H2SO4. So H2SO4 is donating one H plus. This H plus is attacking there. So it is releasing as H2O. H2O के लिए here it is releasing as OH minus. If OH minus is released from HNO3 means the remaining part is NO2 plus. Understood? OH and O2. Imaginary line. Here OH minus means NO2 plus. Right? So NO2 plus. In the chlorine case here Generally the misconception is SO3H is there, of course attacking, but important is SO3 is the electrophile. It's not SO3H, it is SO3 is the electrophile. Next, Friedel-Crafts reaction. Here methyl carbocation, right? CH3 plus is the electrophile. How it is generating means in the last class already we discussed. You can see the mechanism. Uh, which of the following undergo hydrolysis most easily? See, nitro groups are there, easily it can take place. So D is the answer. The product of the following reaction, chlorobenzene, FeBr2. See, whenever Fe this is there, obviously this reaction takes place in the benzene ring. Of course, ortho position and para position. Para is the major, but both are there. So C. The most reactive towards SN1. SN1 means carbocation should be stable, it should be present. So more resonances are there, more is the benzyl. Benzyl is equal to tertiary carbocation. Tertiary carbocation. So here double bond is there, it's not possible. Here only secondary. Here again benzyl is there, but this benzyl NO2 is taking back electrons. Okay, that's why it is not much stable. So next A is the answer. So A is the answer. Then which of the following is used as insecticide? Insecticide is the DDT. For preparation of DDT, we are taking. It's not. It's okay. A and C both. Chloritone also we are using. Which are the insecticide, right? Insecticide. No, chloritone is used as a marsh gas in the bullets firing. Smoke के लिए we are using chloritone and chloropicrin. Yeah, chloropicrin is the insecticide. DDT and chloropicrin. Okay. If you have any doubts, you can share. Then I will make one more video for all doubts. Bye.